All right, so let's take a look at lecture 15 a little bit today. Refresh my memory a little bit. You know, I do teach a few classes, so sometimes I forget. What all did we cover last time? What was the topic?
Operational functions.
The operations of functions. Composite functions.
What is a one-to-one function? Basic transformation and domain of it.
Perfect. Okay. So lecture 15, we'll take the next step. Lecture 15, we talked, this is a short one. It shouldn't take us too long. Hopefully we can cover this and give you time to work his homework before our first person leaves. This one is actually going to be inverse functions. Inverse functions. So someone define for me what was a function. Okay, so for shortcut version, we did for every x, there's at most one y. Okay. Very good. Then what do we say about a one-to-one function?
For every y, there's an x.
Sure, it's a function, so every x there's only one y. But then one-to-one would be, okay, for every y there's only one x. It's one-to-one. Okay. So with inverse functions, first of all, to have an inverse, I'm going to put a little note here. To have an inverse, it must be one-to-one. So when I give you a function, say find its inverse, if it's not one-to-one, it's not an inverse. It doesn't have an inverse. Okay? It has to be one-to-one. So linear always have an inverse. Cubic always have an inverse. Reciprocal always have an inverse. Quadratic doesn't always have an inverse. Okay? Many times they don't. So we'll talk about those kind of things as we go. So, definition. Let f and g be functions such that and I'm just going to put ST, okay, stands for such that. So let f and g be two functions such that f of g of x, all right, what's that notation? F of g of x, what's that? Starts with a C. Composite. Okay, lecture 14. That's a composite function. So if I take g and I put it into f, f of g of x is going to equal x. And number two, g of f of x is going to equal x. And it's denoted, oops, f negative 1 of x. So, if I take a composite function, which we learned in lecture 14, and I realize that, okay, it has a one-to-one, it's a one-to-one, we did that in lecture 14, it is one-to-one, so it has an inverse. If I do the composite function, which we also did in lecture 14, f of g and g of f both, and they equal x, well then that's going to be its inverse. That's going to be an inverse function. Now, what does an inverse do? What's the inverse operation of addition? What do they do to each other? Cancel each other out. Okay. What's the other inverse operations? Multiply and divide. Another one. I'll give you one. Square and square root. Is that what you said?
I was going to.
Oh. So then what's the other one? And cube and cube root. Very, very good. Another one? Quadratic and what? Well, that's square and square root. How about exponential and logarithmic? Right, those are opposite operations. Those are also inverse operations. Those are also inverse functions as well. Okay, so inverse functions undo each other. Okay? Let's give an example. One type of homework problem you're going to see, Roman numeral 1. It's going to say verify. In other words, it's going to give you two functions. You have to tell me yes or no they are inverses. So it's going to say verify. So let's give you two. Let's say f of x equals a really simple little linear problem, 3x plus 2. And then let's give you g of x, which happens to be something like x minus 2 divided by 3. And the directions say to verify. All right, so to verify, we simply start with f of g of x. So f is on the outside, so I'm going to write 3x plus 2. So I write 3x plus 2, that's the f function. And then what's going to go in place of x? X minus 2 over 3. Okay? And then we're going to simplify. I have a 3 in the numerator, a 3 in the denominator. What happens to those two 3's? Cancel. I have x minus 2 plus 2, which equals x, thank you. Because negative 2 minus 2 is 0, so it just equals x. Does that mean the criteria? Let f of g of x equal x, it met that one. But the second one has to be true as well. You may come across some where the first one equals x, f of g, but when you reverse it, it doesn't equal x. So you have to check both. So let's go back and let's check the second one. Sure, another page. Okay, so g of f of x. Okay, so I'm going to write the g is going to be x minus 2 divided by 3. So then what goes in there?
3x plus 2.
3x plus 2. And then we simplify. If I take away those parentheses, I'm pretty much left with 3x plus 2 minus 2, which is 3x over 3, which equals x. Therefore, I can say that f of x equals 3x plus 2, and the inverse, oops, actually do it so it makes sense here. And the inverse, f to the negative first of x, is going to equal x minus 2 over 3. G of x equals its inverse. that make sense to y'all? Does that get it? You good with that? Would you like to see a second way to verify, just for fun? So I got a yes. You said no. You said yes. I got a yes. Okay. Sorry, it's official. We're going to find a second one. Okay. All right. Are you good? Is it okay if I use the exact same function?
Oh, sure.
Okay. I appreciate it. So we're going to go f of x equals 3x plus 2. G of x equals x minus 2 over 3. And it's going to say verify. All right, so let's pick a number, not 0 or 1. 0 and 1 has some special properties.
Wait, what are those three dots mean? Like a triangle?
What 3 dots?
The one that was on the one before.
Here?
Yeah.
Therefore,
There.
because of what we just did,
Gotcha.
this is how you can write it. No, that this is. Okay. So let's pick a number. What do we say? Not 0 and 1?
6.
You can pick 29, you can pick pi, you can pick negative 47. I would always pick 2, it's kind of easy. Now, as you look at the problems, you might want to pick a number that kind of makes sense. This one's linear, so it doesn't matter. So just find f of 2. 3 times 2 plus 2 equals class? 8.
8.
Now, if g of x is a function, I should be able to take that 8, plug it into the g function, and it should do the inverse, which means it'll take me back to what I started with, 2. It should take me right back to where I started. So let's see. Let's plug in the 8. I get 8 minus 2 over 3, which gives me 6 over 3, which equals 2. So 2 is where I start. If it doesn't, they're not inverses. Second way, that's not always the easier one, but it is nice. Were you going to say it was easier?
I was
Nice.
going to say it.
I said that's nice.
It's nice. It's not, oh, these are 2 linear ones, so that makes it real simple. If they're not linear, it's not always easy. But it does work. You can do either way, I don't care. Both of them work to verify. Alrighty. Alrighty. Number 2. However, most of the time it's not going to ask you to verify. Most of the time it's going to ask you to find. So rather than verify, I want you to find the inverse. Well, those of you from Algebra 2, I know had it. It's been a while. Those of you from College Algebra, I know we did it there as well. It's really going to be 2 steps. Number 1, we're going to switch the x and y. Now, that's assuming, I assume you all know, that if I write f of x equals 3x plus 2, that's the same thing as y equals 3x plus 2. F of x and y are kind of interchangeable. I'm kind of assuming you know that. Okay. So we're simply going to take the x and the y and we're going to switch places. Number 2, we're going to solve for y. And that's it. Switch for x, switch x and y, solve for y. Let's give an example. Let's do a kind of an easy one. Let's go with some sort of linear function. Let's try f of x equals something simple like 2x minus 1. Well, first of all, I know this is the same as y equals 2x minus 1, correct? You good with that? So I'm going to take that x and the y, I'm going to switch places. x equals 2y minus 1. Switch the x and the y. Now I'm just going to go back to my algebra 1. How do I solve for y? Not divide, I'm going to do the addition subtraction first. So let's add 1 to both. So x plus 1 equals 2y, and now I'm going to divide. So then y is going to equal x plus 1 over 2. Therefore, we can say that the inverse of x is x plus 1 divided by 2.
Replace.
And if I were on a test and I had time, I would go ahead and verify that just to make sure it works. Plug in something like 3 to make it 5, plug in 5 to make it 3, just to make sure I did the math right. Say again?
That's so easy. That makes it, I understand.
Say it again? It looks familiar? I hope so, I'm sure you've had it before. Okay, we did this with a linear. Linear is very, very simplistic. Let's do it with a couple other functions that aren't as easy. Okay? So, another example. Let's do f of x equals x cubed plus 1. X cubed plus 1. All right, so the first thing you're going to do is write it with a y. Y equals, you don't have to write this stuff if you don't want to. I will though. Okay, and then you switch your x and the y's. Now this time x has an exponent, correct?
Yeah.
You don't take the exponent with it. You literally make the y the x, and you make the x the y. You just simply switch where the letters are. You don't check any exponents, any other things with it, any coefficients. You just switch the two letters. And now you would solve for y. So we'll subtract 1 first. Now how am I going to get rid of that third power? What's the opposite?
Divide.
No. Cubed root. The opposite of cubing is cubed root. So I'm going to take the cubed root of x minus 1 is going to equal y. Therefore, the inverse is the cubed root of x minus 1. Okay, let's do one more.
Hey.
Actually, 2 more.
Okay.
Are you good there? What? Example. I'm just going to write it with a y rather than do the whole fx and write it twice. So y is going to be equal to 5 over x plus 4. So literally just change the x and the y. X equals 5 over y plus 4. Okay, I'm going to show you a little trick on this one, a little mathematical magic, a little shortcut, if you will. What do I do first? Subtract 4. Or, you're right, there's no such thing as subtraction, so add a negative 4. So I'm left with x minus 4 equals 5 over y. And we have that y in the denominator, right? What am I going to do to get that y to the numerator? How am I going to solve this one? What did you say? I can multiply both sides by y. That's one way. Is that what you said? By 5? I can't multiply by 5. I'm already doing that. That would just be, if I multiplied by 5, that would be 25 over y. I'm still kind of stuck. So I kind of gave it away. We're going to multiply by what? Multiply by y. That way, the y in the denominator and the y in the numerator cancels. So then I'm going to have y times x minus 4 equals. All right, now how do I get that y by itself? Don't say distribute, because we don't want to distribute.
We don't.
We don't. Divide by what? No, I just multiplied by y. I wouldn't want to divide. I just
X.
divide by the whole x, the
Minus
whole
one.
expression. Divide by x minus 4. Therefore, y, which is going to be the inverse of x, is going to be equal to 5 over x minus 4. There you go. All right, last one. Last example. I'm once again not going to write f of x, just going to write y equals, let's just go with x squared. Now, I'm going to put a little star by this one, because there's a problem with it. What's wrong with y equals x squared? Why would there not be an inverse to this one? Because why? Yeah. Failed vertical line or horizontal line test. It's not 1-to-1. Okay? So notice what happens when I try, because I promise you more than likely you will try to solve one like this without checking it's 1-to-1. So let's see what happens. If I were to switch the x and the y, x equals y squared. How do I undo that square? Square root. And when I do the square root, I have plus or minus x equals y, and I end up with 2 distinct answers. Now, there is a way around that. Real quick, just want to talk this through real quick. I can actually have an inverse of a quadratic if I do something. Okay? Let's go back to the quadratic. What's the domain of a quadratic? Yeah, so we could say negative to positive infinity, or you could have said all reals. Okay? Well, if I limit that, if I do a limited domain, and let's just ignore this side of the graph. Oops, I erased the whole thing. Let's just ignore the left side of the graph, and let's just pretend the right half exists. Okay? And I say, let's just go from 0 to infinity. If I limit my domain, does this function, just this half, does that pass the horizontal line test? It does. Absolutely does. So, going back to this one, if I say x domain is, whoops, I want to bracket another parenthesis, is 0 to infinity, then which one of these two do I want, the positive or the negative? I want just the positive. So then my answer would be square root of x equals y, which would be the inverse. If I just limit that domain and say, I only want to look at a part of it. When we get to trig later this year, remember that trig, highlight it and put down, maybe put down trig functions. Because when we get to trig functions, we're going to do that exact same little trick. If you don't know, you can see them up there. But if I were to graph the sine of x, the sine function looks like this forever. Okay? Does that pass the horizontal line test? No. So it really doesn't have an inverse unless I limit the domain. Okay? So we'll come back to that when we get to trig here in 6 weeks or so. So for right now, just know, if I limit that domain, I can actually have an inverse, even if it's 1-to-1. Finished well before you left.
Okay.
See? You gotta stop using chalk when I work. Okay, time is yours. Homework is out there. I'll actually put it back up here on the board. Some of you still need to finish 1.7 or whatever left for 14. But here's the new one, 1.8. Not sure 15.